Okay, guys, so yesterday, or the last class, we learned kind of the simplifying the rational expressions, and we compared it to simplifying fractions, just simple fractions. We're going to do that same thing today, except now we're going to look at the different operations, so adding, subtracting, multiplying, and dividing these complicated fractions. So let's just start off with addition and subtraction. So let's start off with a simple example like 2/5 plus 8/5. Okay, somebody explain to me how I would add these two fractions together. Okay, Alex?
The two on the top you would put together to create 10.
Okay, so I do 2 plus 8 across the top, that's 10. What about the bottom?
The bottom stays the same and stays as 5.
Okay, so I have to have a common denominator in order to add and subtract, and just a little FYI spoiler alert, all of them that we'll do in this class will have common denominators. Okay, when we're adding and subtracting, they'll all have common denominators. It's more of an Algebra 2 standard that you will be finding common denominators with rational expressions, okay? So my denominator stays the same when I'm adding and subtracting fractions. And then is this done? 10 over 5?
No.
Then I obviously have the same process of simplifying my fraction here. 10 divided by, or 5 is 2. So I add or subtract the fractions together. And I always have to double check and make sure I can or cannot simplify my fraction. Okay, how does subtraction work? So say I had 4/5 minus 2/5. So how does this work? It's basically the same thing, except I'm subtracting across the top this time, right? So I have 4 minus 2 is 2, and then the 5 stay the same. So adding and subtraction, and then I can't simplify that at all. So adding and subtracting fractions is basically just the process of adding or subtracting the tops, and the denominator stays the same. So the same concept holds true here. So let's pull over to our more complicated examples and look at them. So A should be pretty easy here. Add across it, so I have common denominators. So what is my denominator going to become? Yeah, I kind of made it a loaded question on purpose, right? The bottom doesn't become anything, it just stays the same, right? What about the top? 7, right? So I have 7 over x plus 3. Can I factor either piece? No. Can I simplify anything? No, so I'm done. And just a little FYI, I know you guys are going to be happy about this. I'm not going to make you do restrictions on the operation problems, okay? You will have to do restrictions for the simplifying problems on your test or anything, any assessment. But as far as the operation problem goes, I'm not really going to make you do your restrictions, okay? All right, so that's the final answer on A. Let's look at B. Now, B looks a little more complicated, but if we go back to like the first or second day of Algebra 1, you should all know, and back to middle school even, you should know how to combine like terms, right? What does it mean for them to be like terms? Same variable and exponent, right? So here, what can I combine together? What? Y and 3y. So y plus 3y is 4y. What about that minus 20? Stays minus 20, right? What's the denominator? Y minus 5 stays. Is this done? No, it's not. Why is this not done? A GCF on top, right? So I can do a GCF of what on top? 4. So I got to finish out my problem here. So if I bring a 4 out, 4y divided by 4 is y. Negative 20 divided by 4 is minus 5. My denominator stays the same because I can't factor that. Now can I take anything out of the top and bottom? Yeah, my y minus 5s cancel out. And I'm left with a big old huge answer of 4. You can put 4 over 1 if you want to. The one on bottom is not absolutely necessary. Questions? Okay, can I get a comfort level on adding? Sweet. 4 is not an option, but good. All right, example 2. Now I'm just subtracting. A should be really easy. B might be a little tricky, okay? So A should be really easy. I subtract across the top. 4 minus 2 is -2. Oh, gotta get my pen, sorry. -2. I have t minus 2 on bottom. I cancel out my -2's, and I'm left with 1 over t. Booyah.
So you can just take out -2.
What?
You can just take out -2. So I thought t and -2 was combined.
You were supposed to
Never mind, just keep going.
It's getting close.
I don't want to never mind. I just am curious if anybody's gonna agree with you or not. Can you say what you said again?
T and -2 are combined.
Okay, so on the bottom I have t minus 2. Can I take the -2 out of top and bottom?
No.
That was a test, and guess what?
Everybody else failed.
Caleb passed.
I was really confused.
You were really confused?
Caleb,
Trusted you, Mr. Craw.
All right.
but you said you did factor.
All right. Yeah. Now that we actually know what the right answer is, now everybody's a genius all of a sudden. No, I'm just kidding. I didn't lie to you. I just made a purposeful mistake just to see if anybody would catch it. Okay, so all right, back with me. So since on bottom t minus 2 is a subtraction problem, I cannot take the -2's out, right? So good job there. All right, B is a little bit trickier, so I want to pull it over to the side and ask you to answer this question for me. Answer that question in your groups really quick.
No idea.
Minus 1. Yeah, x minus 1, right?
Okay, how do I do this problem? Because the subtraction sign in the middle kind of throws a kink into things. You guys remember our technique to make sure we don't miss signs? You switch the signs to remember change, or add the opposite, whatever you want to say. Okay, I'm going to change. So I'm going to make this a plus in the middle. Then positive 2x becomes negative. Positive 3 becomes negative. Then I can combine like terms. 5x minus 2x is 3x. 2 minus 3 is -1. This same concept applies here. What we have to remember is this subtraction sign applies to every piece after it. Okay? So that's important for us to remember here. So I'm going to get rid of that. And now let's look at B. So this subtraction sign right here applies to everything on top, the B and the 7. So it's important every time I have a subtraction problem like this to change. So positive B becomes negative, positive 7 becomes negative. Now I can add across the top. So essentially every subtraction problem, you're going to turn it into an addition problem, and you already know how to do addition. You all gave me 3's on that already. So we just add across the top. 7B minus B is 6B. -2 minus 7 is -9 over 3b plus 6. Always do your discount double check. Oh man, I just recorded that. I'm probably going to get copyright infringement. Oh well. Do your double check and make sure you can't do anything. Can we do anything here? Yeah, I can do a GCF on top and bottom, bro. Right? So I was going to say both, and
I thought you said
bruh just came out. All right, so what can I take out of the top? 3. So if I bring a 3 out, I'm left with 2b minus 3. And on bottom, I can also bring out a 3, so I'm left with b plus 2. So what can I cancel?
3.
Just the 3's. Wait, can I cancel the b's?
No.
No. Part of addition and subtraction. All or nothing, right? So I'm just left with 2b minus 3 over b plus 2. Okay, there are 4. Try these down there, but for the sake of time, just do 3 and 4. So do a discussion group here. I want you to do 3 and 4 together in your groups. Go ahead. Okay, so let's go over this here. Since I see a subtraction in the middle, I need to change on top of the second fraction. So I change it to addition, That's going to be a negative 3c and a positive 4. Don't forget about that positive 4. So now I'm just combining like terms on top. 2c, take away 3c's, I'm left with negative 1c. 1 and 4 makes plus 5. On bottom I have 5m plus 2. Can I factor either piece?
No.
Can I reduce anything, top or bottom?
No.
What about my 5s?
Leave them like that.
No.
Leave them like that because they're involved in addition and subtraction, right? It's not 5 outside the parentheses, so that's my final answer. Okay? And then 4. There was some question about 4, and that's okay. So can I combine anything on top?
No. Yeah.
I can't combine anything, right? There are no like terms. I see an x squared and I see a negative 16. So what do I have on top? It's just what you see, right? X squared minus 16. And my x minus 4 stays on bottom. Remember, my denominator doesn't change. Can I factor the top? Yeah, it's a difference of squares. Do you guys remember difference of squares?
Yep.
Okay. So I take the square root of both pieces, add and subtract, right? So the two things that would give me x squared on top would be x and x. The two things that would give me negative 16 are plus 4 and minus 4. So there's my x plus 4, x minus 4 for my difference of squares. Can I factor the bottom? If it was x squared minus 4, I could, right? But since there's no x squared, there's no need to factor, so it's just x minus 4. If I was just doing a traditional simplifying problem, this is where I would find my restrictions. Since we're not doing restrictions, we can go ahead and cross out x minus 4 is on top and bottom, and I'm left with x plus 4. You can put over 1 if you want to. It'd be right either way. Okay, so now can I see a comfort level on adding and subtracting? Let's see where you're at. Adding and subtracting. Sweet. Okay, so we're mostly 2s and mostly 3s, so that's good. Okay, so now let's kick it up a notch, and let's look. We'll actually not necessarily kick it up a notch. So I need you to shut off the half of your brain that controls addition and subtraction. Remember, I always tell you guys to put the addition and subtraction on half your brain, multiplication and division on the other half. Okay, shut the addition and subtraction sign off. Turn the multiplication and division sign on, because here we go. All right, so let's think about it. Just like we started with a simple example with addition and subtraction, let's start with a simple example here. So, about 2/5 times 8 halves.
Cross out. It'd be.
Okay, I don't cross multiply unless I have a proportion with an equal sign in the middle.
You multiply across.
That's it, right? Just multiply across. Don't make it harder than it has to be. Okay, so let me ask you a few questions really quick. With multiplying, do I have to have common denominators? No, I don't. With multiplying, am I ever adding or subtracting top or bottom? No. With multiplying, am I ever keeping the bottom the same?
Yeah, but.
No, I'm always multiplying across, right? So that's why I told you, turn off that addition and subtraction half, because none of those rules overlap, right? So I'm just multiplying straight across. What's 2 times 8?
16.
16, and on the bottom 5 times 2 is 10. Now I can simplify, and a 2 comes out of both of those, and I'm left with 8 over 5. Yes, sir?
Can't you just cross out the 2 2s?
You can. You can cross reduce if you want to.
Which one do you want?
One I made up over on the side. Caleb brings up an interesting point. He found an alternative way to get to 8/5. You can't cross multiply, but you can cross reduce, right? So since I see this 2 on top and bottom, I could have reduced that first and got my 8 left on top, my 5 left on bottom, and got the answer that way. So it's important to be able to see I can go multiple routes to get that same answer. Yes, sir?
Does that work for like every problem you do, or?
Yeah, you can cross reduce. I mean, not every problem you are able to cross reduce, but if you can cross reduce, it will work. Okay? All right, so let's get rid of this and pull over to our actual examples. Whoa. So let's look at example 3. Okay? All right, so here's the deal. there are what I will call loose pieces and expressions. Okay? I determined that I would say that all of these pieces in part A are loose pieces. Loose pieces, you're going to go ahead and multiply them together, but the expressions, you'll see that it's not really helpful to go ahead and multiply them together. Okay? So we'll kind of see that in a second, when it's useful to multiply and when it's useful to just kind of leave them separated. Okay? So let's see here. So we could go Caleb's route and cross-reduce, or we could just go ahead and multiply our pieces. Either way is fine. Which way do you guys prefer? Cross-reduce first before we multiply? Okay. So what do you see right now that I can reduce on top and bottom? 3 and 9. So what can I take out of both of those? 3. So I'm going to make this a 1 and this a 3. Anything else I can cross-reduce?
No,
X's are both on bottom, so I can't do that. Is that it?
Yeah.
Okay, so multiply on top. 1 times 4 is 4.
4,
And what do I have on bottom?
3x to the
3x to the third. Good. Okay, so that was a pretty basic example. Okay, let's look at one that's a little bit harder.
Wait, so that's it?
Sorry. Yeah, that's it. There's nothing. I mean, you always want to double check and make sure you can't reduce anything else, but 4/3 doesn't reduce. There's nothing to cancel the x's with. Yes, sir.
So you don't have to put, like, since you took out a 3, you don't have to put that, like, on the outside, like, on parentheses?
No, because I divided it out of top and bottom.
Okay.
So it canceled top and bottom. It's not like a GCF where I'm just taking it out and putting it outside the parentheses. Okay? All right. So let's look at B. So first off, are there any complicated pieces that we need to factor down?
Oh, yeah.
I don't see any of those pieces that need factored. So now I can go ahead, like Caleb said, and cross-reduce. Anything I can cross-reduce? X plus 4. Anything else? What about my 2's?
No.
No?
No.
All or nothing, right? What about my x's?
No.
Same rule, all or nothing. I can't take that. So what am I left with on top?
2x.
2x. What am I left with on bottom?
Minus 2.
X minus 2. Good.
You're welcome.
Okay?
Now, once I find the solution.
Now sometimes, so these are done just like we did fractions. Sometimes they're not as easy in the beginning. And let's look at something like that, okay? So scroll to the next page. Okay, so it says sometimes the problems are not in simplest form. Always try, let me zoom in here a little bit. Always try to factor and reduce before you multiply. Okay?
What is
Yeah.
Sorry, I didn't get this. What's the multiply rational expression? It's just like you
Multiply fractions.
fractors.
I don't know why I've been saying fractors all day. Mixing my fractions and factors to make fractors.
You're still spitting gold.
Still spitting gold. Nice, thanks. Okay, so let's look at example 4, and let's try to factor it down into simplest parts and reduce all I can. So first off, are there any pieces you see that I can factor?
Yes.
I see one piece.
4a plus 8.
4a plus 8b. What can I do to that?
You could take the 4 and reduce it.
A GCF of 4, right? So I'm just going to put it right above it. So I'm going to take gotta get the pen out. Take a GCF of 4 out. So 4 divided by 4, or sorry, 4a divided by 4 is a. 8b divided by 4 is plus 2b. And I'm just going to mark that piece out because I factored it. Okay, now let's cross-reduce. Anything you see I can reduce on top and bottom?
A squared and A squared.
Okay, a squared and a squared. Because neither one of those is involved in addition or subtraction, so that's good. What else?
The 4.
What?
Yeah, the 4.
The 4s, okay. Anything else?
B. Now,
A single b, right? I have 1 on top and 3 on bottom. So I take that 1 off the top, and now my exponent down on bottom is 2 for b squared, because there's still 2 b's left down there. Anything else? 12 and 20 will reduce, right? They don't come out nicely, but what can I take out of both of those?
2.
Bigger.
4.
4. So if I take a 4 out of 12, I'm left with 3. If I take a 4 out of 20, I'm left with 5. Now this is, you can kind of see it gets a little messy as you're reducing. So you got to be careful. You got to make sure you leave stuff there that should stay there and get rid of stuff that shouldn't. Anything else anybody sees? We can always come back and do our double check at the end. You want to write out what we have and then we'll see what we can do?
Yeah.
If we can do anything else? Okay, so what are we left with on top? 3 and A plus 2B. So I just stick that in parentheses. I'm not going to actually multiply those together. I'm just going to leave them separated. What am I left with on bottom?
20B2.
I don't have 20 left, do I?
Jake,
5B squared.
Yeah.
Okay, now do your double check. Anything else I can take out of top and bottom? My B's? Yes or no? No. Right? Because A plus 2B, that's involved in addition, so I can't do that. Anything else? That's it. No, I'm saying that's it for the problem, for this problem. Okay, so I factor the pieces, cross-reduce what I can, and then the rest is just kind of written together. Okay? All right, let's look at B. B doesn't look that bad.
Oh, yeah.
Actually, because it's.
All right, so remember when I told you guys you were going to get really good at the shortcut?
Yeah.
All right, here goes nothing. I realize not all of you will think this fast, and that's okay. Obviously, you're not going to be racing for the factors on your test. You'll be able to take your time and do it at your pace. For the sake of time, I'm just going to ask you guys to call out answers, okay? So we're doing our shortcut here. So top left, what multiplies to 9 and adds to 6?
3.
And 3. So T plus 3 and T plus 3. Okay, mark that piece out. All right, bottom left, what multiplies to 25 and adds to negative 10? Negative 5 and negative 5. So T minus 5 and T minus 5.
That's what I was thinking.
Okay, top right, what multiplies to negative 20 and adds to negative 1? Negative 5 and positive 4, so negative, oh, almost missed my x there, or t, not x. T minus 5 and t plus 4, so we're just doing our shortcut 4 times. And then bottom right, what multiplies to 12 and adds to 7? 4 and 3. So t plus 4 and t plus 3. See, it wasn't that bad.
Yeah.
All right, cross reduce. Let's see what we can get rid of. So start shouting stuff out. What can I get rid of?
T plus 3.
T plus 3. Okay, let's start there. T plus 3, T plus 3. All right, next.
T minus 5.
T minus 5 and T minus 5. What else?
That's it.
T plus 4.
Ooh, I see T plus 4s.
Oh,
Nice, Chad.
So does Chad. T plus 4. What?
Can you do it if they're not diagonal?
yeah, that's what I was.
What are you talking about?
Yeah.
They can be in the same fraction, right? We did that when we simplified fractions.
Wait, where's the
Right?
T plus 4?
They don't have to be diagonal. No, they just can't both be on top or both be on bottom.
Wait, where's the other T plus 4?
Right here.
Where?
Right here, right here. Okay, anything else?
That makes sense.
All right, so what's my answer?
T plus 3 over T minus 5.
There you go.
I know.
That's your answer.
I think we're done.
Either way's fine. All right, can I get a comfort level on multiplication? Swift 2.5. All right.
This pencil's made of rubber.
Okay, you haven't tried this, go ahead.
What that was from the rubber tree.
You haven't tried this, go ahead. I will give you one warning. Be careful on the bottom right corner.
Where's that at?
The bottom right corner, you have to do both a GCF and a difference of squares. That's all I'm saying. All right, so top left, I can take a GCF of 2 out. Oh.
The x squared.
And I'm left with x plus 1. So there's that piece. Bottom left is a difference of squares. So the two things that give me x squared are x and x. Two things that give me negative 16 are plus 4 and minus 4. So there's my difference of squares. Top right. So this is really stretching you guys. Top right, you have to do your shortcut method. What multiplies to 4 and adds to negative 5?
Negative
Negative 4, negative 1.
Negative 4, negative 1, so x minus 1, x minus 4. Done with that piece. And then bottom right, this one was tough because I see a GCF first of 4, so I bring the 4 out and I'm left with x squared minus 1. And then that is a difference of squares because the two things that give me x squared are x and x. The two things that give me negative 1 are plus 1 and minus 1. Don't forget to bring your GCF of 4 down. And now I've factored everything. What can I cross reduce? X minus 4s? Okay, x minus 4s. What else?
-1.
X minus 1s. What else?
X plus 1.
X plus 1s.
And then you can reduce it 2 and 4.
Okay, I can reduce my 2 and 4. So if I take a 2 out of this 2, I'm left with 1 and 2. So on top, what am I left with? A measly old 1. What am I left with on the bottom? 2 and x plus 4. Yes, sir.
On the bottom left, how do you do that?
So it's a difference of squares. So since I have two terms, and both of them have a perfect square, so the square root of x squared is x, the square root of 16 is 4, I just put those straight into my parentheses. The two things that give me x squared are x and x. Two things that give me negative 16 are plus 4 and minus 4.
Oh.
That's all. That's how the difference of squares works. Okay, are we ready for division?
Can we narrow it?
I don't know how to do these at all.
Divide rational expressions.
No, I just don't
By.
It's because you weren't here yesterday, honestly.
Did we learn a lot yesterday?
I mean, we learned the simplifying process.
Yeah, we
So
learned like the base. I didn't
we'll get you there. We'll get you there. Okay, let's look at division. Okay.
Yeah.
Yeah.
Okay, so let's do this. 2/5 divided by 1/10. Good. Yeah, okay, so flip and multiply, or multiply by the reciprocal, however you want to say it. The first fraction stays the same. And then I multiply by the reciprocal. So what's the reciprocal mean? Flip the second fraction, right? So I flip that to the reciprocal. Now I can go ahead and multiply just like I did before. So you can cross reduce and multiply. Okay, we get the picture? So every subtraction problem I'm turning into addition problem. Every division problem I'm turning into a multiplication problem. So let's do B together. Okay? B.
Why not A?
B. Yeah, let's do B. So first thing I need to do, the first thing I need to do is make it into a multiplication problem. And how do I do that?
You flip it.
Flip what?
Second fraction.
The second fraction. So I change it to multiplication. So I put a multiplication dot over my division dot. A squared minus 36 goes up top. And A plus 5 goes down on bottom. So I get rid of those two pieces. Now I have a multiplication problem just like I did up above. So now I need to factor each of these pieces into its simplest part so that I can cross reduce and be done. Okay? So top left problem, that's 3 terms, so I do my shortcut. What multiplies to 10 that adds to 7? 5 and 2, so A plus 5, A plus 2. That's that piece. What about bottom left? Do I need to factor A minus 6? No, there's no GCF. There's no A squared. Oh, why is it not showing up? Oh, there it goes. It's just lagging a little bit. It's okay. All right, top right is a difference of squares because there's two terms. So the two things that give me A squared are A and A. The two things that give me negative 36 are plus 6 and minus 6. All right, so I'm done with that. What about the bottom right? Do I need to factor A plus 5? No, again, no GCF, no A squared, so I'm done. So let's now cross reduce. So can I reduce anything top and bottom?
A plus 5.
A plus 5. Anything else?
A minus 6.
A minus 6. Anything else? No, there's nothing left on bottom, right? So I have, on top, what am I left with?
A squared, or A plus 2.
A plus 2 and A plus 6. So I stick those in parentheses. And then on bottom I have 1 if you want to or nothing, right? There's my answer.